Okay, so what I'd like to do, attention up here, please. What I'd like to do, I'd like to just zip through a combination of some problems. I mentioned I do this late last week. So I've got some problems from the chapter 7 tests that seem to be a little problematic. We'll just take a quick look at those, maybe iron out some of the misconceptions. And then I pulled up some of the problems from the chapter 8 assignments that I thought maybe we need to take a quick look at. It was kind of a review thing, and I wasn't sure exactly what to cover, but these seem to be the areas that where there are some questions. So, all right, so something like this. There's several kinds of questions that involve this kind of a thing. So this one is asking us just to write this vector in component form, right? So now, real quickly, let's just review what are the two ways that we represent translations or translation vectors. Okay, we've got the coordinate form, and either vector or whatever you want to call it, vector or component. Same thing. Okay, what's coordinate form? How's that one go? And think of what we mean when we say the coordinates of a point. How do we write the coordinates of a point? Yeah, it's just an ordered pair, right? So we'd write it like this. So we've got some point x, y. In coordinate form, we write that as a transformation rule, right? So it looks like x plus some number, call it a, and y plus some number. So what would it look like here if we were going to write this one in coordinate form? xy is transformed to what?
Y.
Say it again.
Y and negative x.
No. So we're starting.
Y goes up 10.
Okay, y goes up 10, and what happens to x? Stays the same. Okay, so we're going to start at that point and end at that point. So we get x. That's it, right? The x stays the same, and then the y goes up by 10, right? So how would we write that in vector component form? So just in general, vector component form just looks like whatever these numbers were, we just put the numbers. That's it. So vector or component form is just telling us how far is the point moving in the x and y directions, right? So what's it going to be for this situation here then? How far is it moving in the x direction? 0. Yeah, nothing's added to x, right? So that's going to be a 0, and how far is it moving in the y direction? Positive 10. Okay, that's it. That's all we're looking for. And remember, these, for the vector or component form, we use the bracket notation, and so those are just the less than and greater than sign. You guys on your keyboard. All right. What about something like this? Okay, I want to take a quick look at this. People are resisting, and if you can do this other ways, but I'm just convinced that the best way to do this is not to try to remember the formulas. You'll just forget them. Always just start off with an XY coordinate plane and then just do the rotation, write the rule. So what about something like this here? If we're going to rotate this point 180 degrees, we'll start off with, so this is positive x, positive y, negative x. And then let's just rotate this whole thing 180 degrees. And it doesn't even matter with 180 degrees if we're going clockwise or counterclockwise. It looks the same, right? And so what's our rule look like? So we're just going to write a transformation rule for this. So we're going to start off with xy, and then what do we end up with? All you got to do is just look at, once you've done the transformation, and I've got index cards. I think the easiest way to do this is just write the xy plane on an index card, and then just do the rotation. So we just want to ask ourselves, whatever goes here, the new x coordinate is whatever ends up there after the rotation. So what is it? Negative x. Okay, the new y coordinate is whatever ends up there after the rotation. So it's negative y, right? And so we end up with, for our specific case here, whoops, we've got the point -9, 8. Well, what's that going to become? Well, there's my x, and there's my y. So we'll just follow the rule. What are we going to get? Yeah, so right, so we're going to get the opposite of x. So if x is -9, then negative x is positive 9. And if y is 8, then we get negative 8, right? Okay, let's just tweak this a little bit. What if we had instead, what if we had done something like a 90 degrees counterclockwise rotation? Okay, what would that have looked like? All right, so okay, so we're starting off, there's our regular XY plane. Now 90 degrees counterclockwise means we're going to go backwards 90 degrees. That would be equivalent to what kind of a clockwise rotation? How far do we have to go clockwise to get the same rotation? 270, right? All we're going to do at this point, later on in math, you'll do different kinds of rotations. We'll do different kinds of rotations, but for now, we're just going to do easy ones. We're just going to do rotations that are in quarter turn increments, so 90-degree increments, right? So there it is. There's our 90 degrees counterclockwise rotation, right? So then let's go back and redo our transformation rule. Okay, so our new x-coordinate is going to be whatever ends up there. Well, what is it? Negative y. Our new y-coordinate is whatever ends up there, so it's positive x. Okay, that's our rule. Just follow the rule. So what do we end up with then? What goes here?
Wait, no, this big.
Negative 8, right? Because it's negative y. Well, this is our original y is right there. So we're going to get the opposite of that, negative 8. Okay, how about here?
9.
Yeah. That's our x. That's all it is. It's our original x. See how that works? And so those, I think there's a little confusion there, and I understand why there is, because it's like trying to say, have you ever done one of those tricks like where if you have like the color red spelled out in blue, it's a lot of, what do you say? You say blue, or your mind plays tricks on you a little bit. So, I know that these are saying, like that says negative y, and so there's a tendency to want to put, or it's in the x position, so there's a tendency to want to put that x coordinate there, but that's not what you're doing, right? You're taking whatever the original y value was, right, before you did the rotation, and changing the sign, and that's what goes in that slot, in the x slot. Okay, so just take your time on those. Be careful. It's easy to mess up on those. Okay, how about something like this? So we already took care of the rotation. How many steps are there in this one? Gene, how many steps are there in this? You gotta read these carefully, right? So I think a lot of times when I look at what people put on these, I'd say more than half the time people miss these because they just didn't read the question carefully. So how many things am I gonna have to do to get my final answer? 2. Yeah, I've got 2 things, right? I've got this translation first. I'm going to translate using that rule, and then after that, once I get that answer, I'll do a rotation, right? But don't miss that first step. Now, the rotation is the hard part. Translations are easy. Translations are the easiest transformations you can do. So if we use this rule, if I start off with the point 13.2, what am I going to get after step 1? Yeah, so all it's telling me to do is take my original x value and subtract 7, right? So 6, and then subtract 11 from my y value. What's 2 minus 11? Negative 9. That's it. Now I'll do my rotation, right?
Oh, and by the way, I think another point of confusion is with these vectors, and I get why this is some new stuff. Do you go from the letter, or do you go? No, you don't. You just go the vector. The letters just represent the endpoints of the vector. That's it. They're just labeling. So we're going from that point there to that point there. So you can either count, or what might even be easier to do is just to ask yourself, okay, so what's that x? My starting x value is 6, and my ending x value is -9. So how far did I move? I had to move 6 plus 9 more. Yes, then I moved left, so it's negative, right? So we go -15. That's how far we moved horizontally. And then what about vertically? Well, it looks like we went from -5 down to -6. So -1 went down 1, right? That's my answer. Okay. Okay. Now, this was probably the most commonly missed question, and it's not a hard question, but let's talk about it. You got to read these very carefully. So it's not asking what I think a lot of people, and yeah. Exactly, it's because it's the pre-image. Exactly, that's why. What people were expecting from this question was the question to say the image of 13.6 is what? And so what was the answer that most people gave me for this? 18, yeah, they would have said, okay, so here's the rule. I'm going to add 5 to the x coordinates, add 0 to the y coordinates. And so most people, in this case, at least the people that missed it, would have said 13 plus 5 is 18. And then 6 plus 0 is 6. That's not it, right? What it's asking for, and you be real careful with this, it wants to know what the pre-image is of this image. In other words, where did we start? Because we always start with the pre-image and end with the image, right? So this is the ending place. This is the image. So how am I going to find that? What do you think, Amelia? What can you do? Yeah, you just want to do the opposite, right? We're asking the question, what plus 5 equals 13? In other words, 13 minus 5, right? So it'd have to be 8, and then what plus 0 is 6? Well, that's just a 6. Okay? Make sense? So these are pretty easy fixes to make. I think if people wanted to go back and do a retake on this, these are pretty easy ones to fix. Okay, now we're on to chapter 8 stuff. And honestly, I'm not gonna hammer a lot of this stuff on the chapter 8 test. The chapter 8 test is gonna focus almost totally on the geometry stuff, which would be kind of the triangle similarity stuff, right? So not so much on this. But I do want you to know how to do this. Going into Algebra 2, this is not a bad thing to review. And I might throw, 1 or 2 of these on. So what about this? During a snowstorm, 3 3/5 feet of snow fell in 6 hours. Assuming it fell at a constant rate, what was the rate at which it fell in feet per hour? So this is what we call a unit rate problem. Okay, and this will come up, this kind of stuff comes up, it comes up on the Smart Balance test for one thing, but it'll show up next year in Algebra 2 also. How are we going to do this? How do we do a unit rate? What's a unit rate problem mean? What's the word unit mean? I know. 1. Means 1. So what we want to be able to do is we want to be able to write this as a fraction. Instead of writing this as 3 3/5 feet in 6 hours, we want to be able to write this as some fraction, some number of feet in 1 hour. So that's what we mean by a unit rate. We get a 1 on the bottom, right? So all we're going to do to get that is we just have to figure out what that number is. We're just going to simplify the fraction, okay? So how do we simplify a fraction like this? I know this is definitely review, but it's been a while. So how do we do that? What are we going to do with the 3 3/5? That's not an inconvenient way to write that as a mixed number like this, because it gives you some idea. That tells us that it's between 3 and 4 feet. So So that's not a bad deal to write it as a mixed number, but when we do math, we do not wanna write things as mixed numbers anymore, that's middle school stuff, right? First step is we gotta convert this into a fraction, a proper fraction. So what are the steps for that? How do I turn 3 3/5 into a fraction? Okay, good, so I'm gonna multiply the whole number by the denominator. And think what that's doing. That's telling us that 3 is the equivalent of 3 times 5 or 15/5, right? But we've got some extra, we've got some leftover, a remainder of 3, so we gotta add 3 to that. So you multiply the whole number by the denominator and add the numerator, right? So then we end up with, in this case, 3 times 5 is 15 plus 3 is 18/5 divided by, what do I do on the bottom? 6, it's a 6, but my recommendation here is you always, whenever you're trying to simplify some quotient of fractions, always write it as a fraction divided by a fraction. So what does the bottom fraction become? 6 over 1. And what's our rule? When we divide by a fraction, we always do the same thing. We don't like to divide by fractions, instead we multiply by what? Yeah, the reciprocal. So when you divide by a fraction, simple rule is you always flip and multiply by the bottom, right? So we would rewrite this as the top fraction, 18/5 times the reciprocal of the bottom, times 1/6, okay? And multiplying fractions is, it's actually easier than adding fractions. You just multiply straight across, right? So now we have the option of multiplying straight across and then reducing, which works. I think it's a lot better though to just cross cancel if you can, so you're dealing with smaller fractions. So how can I cross cancel this one? Yeah, 6 goes into 18 3 times and into 6 once. And so now when I multiply straight across, 3 times 1 equals 3, 5 times 1 equals 5, and so that's my number, right? That's what I'm gonna get in terms of feet per hour. So we could write this as 3/5 feet per hour, right? Or for 1 hour, either way. Okay. All they want you to do is fill in that blank, so it's just gonna be 3/5. Okay. Questions? Okay. So then this is the same kind of deal. Almost the same problem. So if this girl walked 3 2/3 miles in 1 1/6 hours, we want to know how many miles per hour was she walking, right? So all we're going to do is just simplify that fraction, right? So what fraction do I get on the top? What am I going to get on the top here? What's it going to be? 11 over 3? 3 times 3 is 9 plus 2, so I get 11/3 miles. How about the bottom? What am I going to get on the bottom? 1 times 6 is 6 plus 1, 7/6. That'd be hours. But really, the units are going to work out. We get miles per hour. What we want to know is just what's the number of miles per hour. So we have to just simplify the fraction. So what are we going to do here? Let's see. Nick, what am I going to turn this quotient of fractions into? In other words, what do I do right to the bottom? Okay, I'm going to simplify, right? So I'm going to end up with the top fraction, which is 11/3. But I don't want to divide by 7/6. I want to instead multiply by what? 6/7. Flip and multiply by the bottom, right? So that gives us 6/7. Can I cross reduce?
Yes.
Yeah. 3 and 6 reduce. 3 goes into 3 once. It goes into 6 twice. And then I'm done, right? 11 and 7. I can't really do anything with that. So I multiply straight across, and I get 22 over 7. And I can always look at that fraction. You know, what if I don't completely cross cancel it? It's fine. Then I'll just reduce the fraction. Okay. So that's my number of miles per hour. Okay. Okay. This one we talked about a little bit. Once again, I'm not gonna really emphasize this on the chapter 8 test, but this is a good kind of science application. You'll do this a ton in all of your science classes all through high school. So 25 yards per hour, we wanna write that in inches per second. So that's the same as saying 25 yards over 1 hour. Okay, now remind me, how do we do this? How am I gonna convert from yards per hour to inches per second? What's one thing I've gotta do here? What do you think? Tell me one thing I've gotta do. Carrie, what's one thing, how am I gonna get from yards to inches? Right, somehow I gotta cancel out the yards and get inches in their place, right? So this is where we're gonna multiply by a changer. When I say changer, I mean a unit changer. Okay, so Carrie, what unit has to go on the bottom if I wanna cancel yards? Right, I wanna be able to cancel yards with yards, right? So I know for a fact that the one I wanna get rid of has to go on the bottom, so I can do this, right? Well, then what's gonna go on top? What's the unit that I'm trying to get on top? Inches. Good, so I want inches on top. And now all I've gotta do is I've gotta write a quantity of yards and inches that's the same length. So typically we start with the bigger one, which is a yard. How many inches in a yard? 36. So 36 inches equals 1 yard. Okay, that's good. Now we end up with inches on the top, which is what we want, right? But we have hours on the bottom. So we gotta cancel the hours. Okay, so Ruby, what am I gonna do if I wanna cancel hours on the bottom? What unit has to go on the top? Hours, because I wanna cancel hours, right? We already took care of the length unit. We traded yards for inches, so we're done with that part, right? But now I know here I wanna get yards on the top, hours on the top. So the hours will cancel, but then I need another unit of time on the bottom. Well, the one I want is seconds. Maybe you don't remember how many seconds are in an hour though, so let's do this in 2 parts. I could go from hours to minutes to seconds, right? How many minutes, let's make this a minute. Oops. How many minutes in an hour? Okay, so I could go 1 hour is 60 minutes, that's good, but I'm not quite there yet. I need seconds, I've got minutes, right? So now what am I gonna multiply by? I gotta get the minutes to go away and get seconds on the bottom. So Savannah, what unit goes on the top here? Minutes, good. Because we need the minutes to cancel. What unit do we end up with on the bottom? Okay, what's a number of minutes and seconds that are equal? Well, minutes are bigger. 1 minute equals 60 seconds. Okay, so now we're there. Look, we've got our seconds on the bottom, we've got our inches on the top. All we've got to do is just simplify this thing, right? We can do some cross-canceling, fortunately. So how about 36 and 60? What number goes into both? 6 does. So that gives us a 6 there and a 10 there, and I can even go a little further. 6 and 10 reduces to 5 and 3. Okay, or I could even do this. How about 6 over 10? What's that reduce to? Yeah, I can do 1 and 10, right? Is that good? And I can do one more. 25, did I do that right? Yeah. Okay. 6 goes into 6 once, 6 goes into 10, into 60 10 times. How about the 25 and the 10? You can go one step further even. Yeah, okay, good. So 5 goes into 25 5 times, and it goes into 10 twice. And then I can do 5 and the 10. Right? I can keep going. I don't have to do all this. I could just multiply and then reduce the fraction. But it's easier to do it this way because I have smaller numbers to deal with. So last one, 5 over 10. 5 goes into 5 once, goes into 10 twice. So now I'm done. I've got 1 times 1 times 1 times 1 equals 1, divided by 1 times 1 times 2 times 2, so 1/4 inches per second. Okay? Make sense? Okay? All right, what else we got? How about this? So it says solve for x. What do we do? And this is huge. This one definitely will be on the test. This is one I really want you to be very aware of. This comes up a lot next year. What do we always do when we're solving a ratio equation or proportion? The problem with this is it's a fraction. Fractions are hard to deal with, right? So what do we always do when we've got some kind of an equation involving variables that's written in fraction equals fraction form? How do we get rid of the fraction form of this? What are we going to do? What do you think? Walter, what do we do in a situation like this? How am I going to get rid of the fraction part? Okay? Ideas? All right, ideas. Okay, so this is important review. We always cross multiply, right? If we cross multiply, then that's going to take this fraction and it's going to rewrite it as a non-fraction equation. So by cross multiply, remember all that is we're going to multiply that cross product, and that's going to give me x times x gives me x squared equals that cross product. Okay, 8 times 32 is 96.
No.
What is that?
Yeah.
126? No, 256.
Yeah.
Okay? Okay, so there's our, now that's better, right? Now there's no fractions. This is a little bit different. We'll talk a lot more about this next year, but you guys know how to deal with this, I think. What do you do if you have, I want to unlock that x, right? You've got an x by itself. All I have to do is reverse order of operations. Well, the only thing I have to do is undo a squared, which I do by square rooting. So I get x equals, and then the square root of 256 is 16, but what do I have to put there? This is the part where people have trouble. Has to be a plus or minus. Okay? Whenever we square root both sides of an equation, you've got to include a plus or minus. So there's two answers to this one. How are you going to put this in Moodle? Well, you just write it like this. It doesn't matter the order, but like negative 16, comma 16, or vice versa. Okay? All right, let's look at one more of those. What about one like this? Once again, I've got a ratio equation. What am I going to do? Cross multiply. Okay, so let's look at this cross product. This one's going to give me x times 9 is 9x equals, this is the one you got to be careful with. What about this cross product? Now I've got 6 times the quantity times the whole thing, the quantity x plus 4. So we'd write it as 6 times in parentheses because it's a quantity x plus 4. Now, you guys are getting very, very good at algebra. I mean, I think this is a piece of cake. What do we do here? Okay, I've got to simplify, so I've got to distribute the 6. So now I've got 9x equals 6x plus 24. Now what? Push the x's to the left, where we'll get a positive number. So subtract 6x from both sides, and then divide by 3 and get 1. 8. How can I check this, by the way? Plug it in. Okay. Here's another one. This is kind of a challenge question, but I think it's worth taking a quick look at. Okay, what does this mean? We know that the perimeter of a rectangle is 306, and they tell us the ratio of the width to the length is 7/10, right? So we could write that as, I mean, are they 7 and 10 though? No, right? If I'm gonna draw this rectangle, we don't know what the actual width and length are. We just know that the ratio is 7 to 10. If this is 7 and that's 10, well, that's not going to add up to, when I add up the perimeter, it's not going to be 306. Right? that's the simplified ratio, okay? So it could be 70 and 100, but that's not gonna work either. What's it gonna be? We don't know for sure, but we know that if the ratio is 7 to 10, we know that we're gonna have to multiply each of these by some number to get the right answer, right? But they're proportional, so we have to multiply them by the same thing. We don't know what it is though, so let's call it x. Right? We don't know what x is, but we can solve for it. If I know that the width, the ratio of the width to the length is 7x over 10x, well that's just equal to 7/10, isn't it? Right? Everybody see that? Because the x's would cancel. What does that make the perimeter then? If I'm calling the width and the length 7x and 10x, how can I come up with an equation that says the perimeter is 306? Well, okay, so if this is 7x and that's 10x, what's this equal? 7x, because it's a rectangle, and what's this one equal to? So the perimeter then is just gonna be 7x plus 7x, 14x, plus 10x plus 10x, what's that all add up to? 34x. So 34x has to equal 306. What can I do there? Yeah, I can solve for x. If I can find out what number x is, I could plug it back in and figure out what the width and the length actually are, right? So if I divide both sides by 34, it's 9. We get x equals 9. Good. So now we know what the actual length and width are, right? So that makes the width, 7 times 9 is 63, and the length becomes 10 times 9 is 90. And they want us to find, well, that's all they want, width and the length. So 63 and 90. Okay. Make sense? Separated by comma. We're getting there. Okay, we already did a bunch of these. We don't even have to do the whole thing. How would I rewrite this though when I divide by a fraction? What do I do? What do I do? Good. Yeah, so I flip and multiply, right, Vanessa? Okay, so what's this going to become? What's the fraction on the top? 11. So I'd write that as 11 over 1 times, what's this fraction going to be? Good. 12 over 11. Then that's just 12, isn't it? The 11's cancel. Okay, same thing here. That's even easier in a way because I've already got the fraction on the top and the fraction on the bottom. And then if I did something like that, what's the fraction on the bottom that I'm 1 over 3. Yeah. I'd rewrite this as 3 over 1. Whoops. As 3 oh gosh. As 3 over 1, right? So then this becomes 15/7 times the reciprocal of the bottom, 1/3. So cross cancel. Okay. What's that? No, okay. I only had a couple left to do, but we can do those later. That should get you going.